Generally what we do is, if there is a variable thickness, you'll let me see how to show you this. So let's say if you have a variable thickness like this, what people will do is they'll see, okay, they'll measure it here. So you have one shell like this, a wall of shell, they'll measure thicknesses there, they'll measure thickness there, they'll measure thicknesses there, and they will say, okay, these two rows give it X thickness, these two rows give it Y thickness, this row give it Z thickness. So they'll model this as like this, something like this, right? So now you have to do these many steps, but instead, if you would just say you have this row and you have this parent faces, what if you could just select these shells and select one parent face, and it could give you this kind of distribution? Wouldn't that be amazing? Wouldn't you be able to do something that takes you this process, just this process would take you somewhere around 5 minutes if you were to do manually. This process takes about 2 clicks, which is less than like what, 2 seconds. So that is something you can do, or something we have done already. Again, master model creation. Once the BOM is ready with the collated data, we can just have it read the data and prepare the master model. We don't even have to have that human resource to look at the data and input it manually. Once both of the once the CAD is available, the master model has been created, merge both of the data sets, and you have your master model ready. So then connection creation is a huge task in FEA modeling that can be automated. Or translation between decks. Sometimes you have to have so say you've created a kind of an element like C-bush in, I think, a Nastran, and then you want to move it to a different one, or you create it in, yeah, I think Nastran, and connect up 3Ds in LS Dyna. So when you're translating it, how do you translate it? Will you go and remove each C-bush and connect it and create a new kind of 3D? Or can you write an automation script that will automatically connect this? These are few things that I have worked on. That's why I've them here on. But the fact is, the amount of things you can do is simply limitless. There is no saying what next can be done. Okay. So now let's look at a simple demo. It'll be a very simple demo. So, and I'll run you through that too. Can everybody look, is able to look at my screen and is able to look at the model here? Yeah. Yeah. Is everybody able to look at the ANSA?
Yes.
Yeah. Okay. So let's say this, what it does is, let's say you have here, it's a very simple one. I don't know what this uh, this will do. I mean, how this will be useful to somebody. But what you can do is this. Say I want to take this point and project a plane here. Project a point perpendicular at some distance away with reference to some direction. Okay. So I can say project this point. Now you have this concept here wherein it says project point, okay, where it will take this thing and it will, if you what happened here? So now if you select a face, it won't do that because it doesn't really have something there. So let's say if we project it from here to here, see, it'll do this. But you don't have an option where you can, I want to offset this in a certain direction, right? There are other ways we can do it. We can say create a line from here, extend it, then extend another line, create that, and so on and so forth. We can do that. Or I said, okay, you know what? I'll just take this one thing, confirm it. Which is the plane you want? I want this plane. I'll take 3 points to describe that plane. Confirm. It'll ask me at what distance do you want it. I'll say give it to me at 10 mm. No, it gave it in the reverse direction because the orientation is there. Okay. Now let's see if it will do the same thing. It's not taking it. So for whatever reason, it's not taking that orientation. Okay. Again, this script was just done without any kind of these kinds. We can actually take a look at that since we have time. We can see why it did not do what it's supposed to be doing. Okay. Say let's take these three, place a plane, take that point and give it to me at 20 mm distance. So it gave me in this direction. So if you now measure it, it's 20 mm, right? What can you do with this? No idea. You can, that kind of an application, this was just done for the demo. So it's something, and one of other of my guys asked me to, they were doing it as a project. So this is their script actually, it's not even mine. So I'm showing it off as a demo to you because they did something, they thought this might be useful for them, so they created this. Okay, but let's say now let's look at how the script actually looks like. Okay, so this is your environment where you'll be doing the scripting. How you can get there is you have this option called script. When you click on that, it will take you to the scripting environment. This is your IDE. This is your editor. This section is where you have all of your API, everything that you need to do anything with this, you have it here. Okay, this is your script and this is your console. Now you have a help section as well, and you have an output section. Output section will show you what is happening. Okay, and how this looks, this is how the general structure of it, like you'll import certain libraries to help you with it, then you're doing a bunch of operations. See, these are all you're writing from scratch, right? That's the best part of it. You're writing from scratch everything. And how it looks is, if you look at this, it's saying get a vector at distance, select a point, get face normal, get a new vector at distance, and main. So if you look at the logic, it'll say, okay, take a point to offset, select the point. This is a method that you're selecting the point and you're returning it. Then you're saying calculate the face unit normal. So I'm calculating a face. I've written this get face normal function. It goes, does that, gives it back the face unit normal. Then I'm saying get the distance from the user. So just GUITK, that's a, so if you look at this here, GUITK, everything that is in red is a ANSA API function. So it's saying, okay, get user input. It gets this input, creates a new vector. Using this and this information, it creates a new vector, then creates a new point, getting this information, and again, creates a new point here. Okay, so new point has been created. Okay, so it created a new point, gets the new point data, creates the new point in ANSA environment. This is internal calculations. It has finally created. So that is when you see this dot. How long would it take for us to do that, and how long has it taken for it to do? Okay. So, and if you look at this, these are all your basic this is from scratch. You're writing the logic. So you're doing GC collect is basically a garbage collection, because ANSA is sometimes it becomes very um, it consumes too much memory. So what you want to do is you want to remove any and garbage collection is a concept. If anybody of you is programming, you will already know. Whenever you're not using any variables, the language will already come and it will start claiming back that place. But there's no guarantee when it has done it, when it will do. So what I do is I actively make sure that I keep an eye on that. The moment I start off, I'll say remove everything I'm calling the garbage collector consciously. And if I'm doing any deletes of any entities or such, I'll use another option called compress as well. That's an internal answer to garbage collection mechanism. So I'm taking the data. I'm see this logic here. How am I calculating the phase? I'm just saying taking 3 points here. I'm still asking the user to collect 3 points using this method. We can then go and decide. I don't want to do that. I just want them to select one face and automatically it will collect 3 points. We can do that as also. That becomes a little more complicated, because what if the 3 points lie on the same line? So you have to do testing for that internally in the logic itself. So that increases the complexity of the code. This is a very simple code. This you can just say, okay, pick 3 points. Okay, you pick 3 points. It's created 3 vectors. It's created 3 arrays. Now it's created 2 vectors. It's calculating the normal vector. It's calculating the phase normal, and it's returning that to you. That's it. Okay, so on with the presentation. So now that you've seen this, so what is the state of art and evolution in this field? Now with automation, the next natural progression is how do you add intelligence to this automation? Automation, now we are saying, okay, there's a step A, step B, step C. Can you please do these things in sequence? What if from step A, you can go to either step B or step D or step C, depending on the input factors? Can you do that? How complex is it? If it's just those 3 steps, yeah, you can automate that too using if else, such simplistic conditional operations. But what if there were 100 different things? And what if there was no clear pattern? That's where the next things are coming in. AI, machine learning, data science. You can use these things to uh, automate with intelligence. That's what I would say. So one of the amazing examples is you can look at this link. I think you can ask the organizer. They can give you this link. I can post it, I suppose. Give me a moment. Let me see if I can post it to you. Okay, I think right now it is not editable, but I can get you that link. So what this does, you can also search for it on YouTube. There is a team that has created a whole chassis design, a frame. It's not just a chassis, the whole frame design, like the frame on the chassis. Actually, it's a unibody design, I think, and they made the design from crash data. They took 100 vehicles, they did all the crash experiments on it, collected data from that, and they fed it to their engine, and that engine now created a whole frame and constructed that frame. If you look at that frame, it looks nothing like a human design frame. It looks as if it's an organically it grew, like how the human bones grow. You look at that chassis, that's exactly how the frame will look. It'll be all kind of an organic shape. It'll have various thicknesses just in that one arm. It'll have 3-4 thicknesses. It'll have rounded shapes, curved features. But how it was designed is The machine took that data, looked at it, saying, okay, this is how the stress distributions are, and this kind of a structure will give you the optimal stress distribution. And it created it all from a data set, no human intervention. How amazing is that? Now think about how many design iterations you can do that. And yeah, so what is a career path about job opportunities? CA engineer is a very, very broad term. You could be a multi-body dynamics guy, and you would still be a CAE guy. You could be just a FE meshing engineer, and you'll be called a CA engineer. You could be a CA analyst, and you'll still get called CA engineer, right? So that's a very broad term to describe it. People will think, okay, CA engineer is this, but you have so many things to do. And with automation as a skill under your belt, you certainly can combine these. Just two factors will introduce such kind of a non-linearity in your job options. You can take any combination. Once you have the skill set, you can be a CA engineer, you can be a FA engineer, plus a data analyst, plus an automation engineer, and go ahead with that. You know what needs to be done. You have to just do it. You can become anything you want. It's because it's a new emerging thing. The definitions are very fluid. If as compared to old definitions, if you look at other job opportunities, they will describe it in very specific manner what they expect from the job opportunity, job role. But that doesn't apply to automation as of yet. It'll be very, very ambiguous kind of definitions. They'll say we are looking for somebody to automate this, think of new solutions. But what exactly will the solutions be like? Nobody knows, because until you hit that problem and face your first failure, you don't know what the solution starting to look like. Solutions will change midway also. You can be you can be an FEA analyst plus an automation engineer, or you can be a machine engineer plus an automation engineer. I'm a FEA analyst and an automation engineer. I handle two, three things. Actually, I'm a CA analyst and an automation, because my job profile, I have to do other things as well. And then look at those processes and automate them as much as we can automate. You can work for companies like Altair or Beta CAE, or even the bigger, like these companies are the ones who create the tools, HM, ANSA. But you can also do work for smaller organizations, startups, right? Or work in OEMs that need customization, like Fiat Chrysler or Renault Nissan or Ford or Daimler or GM, you name it, you have it. And some of them are also going into data science and automotive engineering, like driver drowsiness alert. You would have heard of this actually, wherein they're tracking the eye movement of the driver, and if it's not within a certain range, and if it's not actively moving, or if there's not a change of state in a long time, not long time as in hours, but long time as in like in 2 seconds it has not changed position, it means he's fallen asleep, and it immediately alerts him like that. And just because it has not moved does not mean that it's not actually alert. He's just not blinking. Maybe it has to know the difference. You can't keep beeping continuously every 2 seconds. That will induce irritation. These kind of real like issues, right? Or real-time vehicle diagnosis. Maybe you have vehicle engine data coming in, streaming directly, and uh, you can say, hey, these parameters are looking wrong. Maybe this particular engine is going to fail. There's a upcoming issue in this powertrain. You can alert the customer saying, hey, don't take out your car. Your car is in this kind of a state. Uh, we'll come and collect it. There is an issue, and if we correct it at this point of step, there'll be other repercussions of that failure that can be avoided very inexpensively. You can take corrective measures. Or say you want to do warranty data analysis for root cause analysis. Say how long have one of the things we were doing was this, seeing, okay, what is the problem history of this vehicle. Think it's as an analogous to a human health history. You go to a doctor, the doctor will look at your past history and try and see if there is any marker that points to your current predicament. Similarly, for a vehicle, how many times has this vehicle come to the workshop? What is the progression of each time it has come? What is the progression of the issues? Are there any common issues? If we know that issue B is happening, then definitely issue C will happen. Do we know that for certainty? Are these two lined up? Pass on this data to the design team and tell them, hey, this is what we are observing. Can you do something with your design that will not make this happen? That kind of stuff. Literally the opportunities and the paths that you can take are limitless on this.